Guten Abend, ich begrüße Sie alle recht herzlich hier im naja, mehr oder weniger hier im Eisenbahnwesen-Seminar der TU Berlin. Wir haben heute gleich zwei besondere erste Male. Wir haben zum allerersten Mal einen Redner, der nicht aus Europa kommt. Also britische hatten wir vielleicht schon mal, das heißt, übers Wasser sind wir schon mal gekommen, aber wir haben heute Thomas White hier. Er ist Consultant in den Vereinigten Staaten aus Seattle. Und wir haben zum ersten Mal einen Vortrag auf Englisch, aber ich denke, das sollte hoffentlich für Sie kein Problem sein. Es sind tatsächlich die guten Möglichkeiten, die wir halt jetzt haben, oder dass wir das Beste aus der Situation machen, dass wir halt keinen EWS halt vor Ort haben, sondern online durchführen. Es wäre uns nicht möglich gewesen, Herrn White einzuladen, einfach von Seattle mal rüber zu fliegen, aber aufgrund des Lockdowns und der Online-Veranstaltung klappt es jetzt so auch. So Thomas, thank you for agreeing to presenting here at the Eisenbahnwesen-Seminar. As I told you before, just told everyone that it's two firsts, that you are first English speaker and the first non-European probably to present it ever in more or less 10 years. Maybe someone was here and corrects me, but Heiko said it should be two firsts. The presentation today will follow the normal routes we always have. So Tom will present his slides. He tries to stick to an hour, but if it's one bit longer, I think you're all fine with it. You can always put your questions in the chat. And Heiko, correct me, but we don't need to log in the chat so that we know that you are here. So we are not counting participants anymore. So, but if you want to ask a question, please log onto the chat as always. Tom is prepared to answer everything, which might be very detailed or very general. And yes, I'm really looking forward to hearing your lecture. So the screen is yours.
I'll set up the slides.
So, not there yet? Now.
How about now?
Yeah, it's perfect.
Now, what happened to the control for changing the slides? Isn't the control for changing the slides supposed to be at the top of the screen?
Heiko? I think. Heiko, can you help him? I think you should be just using your normal control, like the arrows.
Let's try that. It works. Okay. Leider meine Deutschsprache ist sehr krumm. So I'm forced to do this in English. So railway operation is similar all over the world. I've worked with people in Europe. I've worked in South Africa. And once you're a railway professional, you can understand railways everywhere. With minor vary, you have to learn. So there's three basic systems. There's the German system, the English system, and the North American system that all evolved separately. Of the three, the North American system is most radically different. Our operating practices are related to politics a lot more than anyone else's. So some of the aspects are kind of portable to anywhere in the world. Some things will make you wonder just how. So anyway, I'm going to delve into something that will probably be as foreign as going to Mars for some people who've never experienced what we do in North America. So the railways in all of North America, Canada, the U.S., and Mexico work as a single network. They're all standard gauge. All of the rolling stock is interchangeable. Couplings, air brakes, all of the safety appliances are all in the same place on every car. They all use similar signal systems and operating rules. There are some variations locally, but they're all effectively the same. They all share the same car movement data system. So if you're a customer who is looking for your freight car, you can make a computer inquiry and find out where it is, no matter which of the 3 countries it's in. They all share a common revenue collection system. The customer, even if a car moves from Canada to Mexico and uses 4 separate railways to do it, the customer gets one bill. The railways take care of it among themselves. And the professional organization, Association of American Railroads, sets all the standards except for the safety standards for the entire North American continent. The U.S. railways belong to UIC, but they're not really participants. They sit on the side and watch and have their own system. The U.S. railways are among the very few in the world that have always been privately owned. During World War I, the U.S. government tried to improve the railways by having the U.S. government run them. It turned out to be really bad, and they just gave the railways back to the private owners. So in the long run, with the private ownership, it creates a problem that you don't really experience in Europe, because each individual corporation has the purpose of making money. They're actually not in the business of transportation. They make their money that way, but the goal is to make as much money as possible. This comes from over 100 years of punitive regulation. When the railway industry started, it was wonderful. It was transportation that the country needed and didn't have. But then once it became essential, people started being upset because of too much power, too much control. So the government started with punitive regulations. They insisted that the industry provide service at prices that didn't make any profit. Over and over again, the industry deteriorated from not having enough money to maintain their infrastructure. Then the government took it one step further with creating our American auto-centric society by competing with the railroad industry early in the 20th century, requiring the railways to use their own revenue that was limited by regulation to maintain their infrastructure, at the same time as the government was building highway systems, canal systems, and airports to compete with the railways. They added to that taxing the railways through the 1940s and 50s in order to pay for the competition that the government was building. So since the point is making money and not providing service, railway research here typically involves figuring out how to increase capacity without increasing infrastructure. making the trains heavier, longer, making the individual cars heavier. We've reached the point now where a normal train is almost 3 kilometers long. The individual cars are up to 150 tons apiece with a 37-ton axle loading. They try to eliminate switching and classification by discouraging individual shipments and promoting unit trains, or block trains as you would call them in Europe. There's no structured or scheduled operations. Were I to show you a U.S. railway timetable, you would see that there's no times. Everything is improvised because the management typically comes from outside of the railway industry. They don't understand the constraints of infrastructure on railway transportation. So to those managers, the easiest way to run a railway is everything at their convenience. The same applies for simulation software. There's a thought here that if you pour trains randomly into a simulation software, that an answer will come out on what infrastructure you need. There's no railway science that's taught, and everything that's practiced is handed down basically from software vendors. We have 2 university railway programs for the entire U.S. One of them is a bachelor's level civil engineering program, in which typically the instruction is in how to build things, but not what to build or why. The other one is a graduate program in which during the bachelor's program, there's no railway instruction at all. And then entering the master's program, they begin with some advanced theory with no railway basics to use as the root of their advanced theory. The railway industry was deregulated in 1980 when they did away with the punitive regulations and switched it over to being corporations that were rooted in only making money. When the new management came in, everything that we did to manage the railways before 1980, which is basically the things you learn in university there, were considered the old ways and were disposed of as quickly as they possibly could. Training before 1980 was typically apprenticeship, and they not understanding the need for specific railway knowledge eliminated the years of apprenticeship in learning railway trades and replaced it with 28 to 36 week schools, where instead of a general education in railways and the knowledge of how the entire system works, they concentrate on the tasks necessary to do a job. So by eliminating the concentration on transportation and eliminating the punitive regulation, what has happened is that the railways have gone from being so deteriorated that there was basically infrastructure that looked like it had been after a war, to a good modern infrastructure. However, it is designed for 4-kilometer long trains, no switching. So the capacity is limited. But in the process of doing that, the railways have become successful in making money. So much so that the Wall Street financial people dictate what the railways do. So you may have heard of something here called precision scheduled railways. It has nothing to do with precision. It has nothing to do with schedule, and very little to do with railways. PSR is basically propaganda to convince Wall Street that railways are good, and it involves minimizing the number of trains, minimizing the infrastructure, and minimizing the employees, and maximizing not only automation, but maximizing the amount of empty railroad. It makes no sense except to Wall Street investors, and they're happy. So as a result of all of this, all of our passenger trains are government subsidized. We have Amtrak, which is the national operator. It is a private corporation, but the government owns the stock. Its licensing is kept to a minimum. They repair cars sufficiently for service with tape. They're outmoded. They're often dirty. The very best reliability of our passenger network is not as good as the worst of Europe. The cities and urban regions, in order to maintain commuter service, have taken it over as public ownership, so that we have government provide the commuter service to the cities. They typically pay the private railways a lot in track access charges in order to guarantee their 90 to 95% reliability. The railway companies, since they prefer a money-making long line haul, discourage any shipment that is less than 1,000 kilometers. They will either charge extraordinary prices or provide terrible service to customers who want to ship less than 1,000 kilometers to make them go away. Most of the branch lines that have not been abandoned have been sold to short line railway owners. They typically encourage service, but have difficulty with their interchange with the main large railway companies, because the short line railways are typically treated like small customers. If the major railway can make them go away, they're happy. And all this is because of the stock market. A stock market analyst is probably the most important and powerful guy in the entire railway industry. If an analyst says that he's disappointed at the quarterly earnings, railway operations change. If the stock price isn't adequate, railway operations change. The planning horizon in the industry is no more than 5 years. If an infrastructure investment can't be repaid in 5 years is just not done. There's no more forward thinking than that, because the question always arises, well, what if business changes and we don't need it anymore? That also means that one of the metrics that's important is train starts. The fewer trains they run, the happier they are. It was interesting many years ago that I had a tour of the control center in Berlin, and the manager told me that his job was to see to it that he ran as many trains as possible on the infrastructure. No U.S. railwayman would ever say that. Their job is to run the fewest number of trains possible. And of course, I mentioned that now our trains are up to somewhere around 4 kilometers long. However, our yard tracks are not 4 kilometers long. Our typical yard tracks are somewhere in the neighborhood of 1 kilometer long. So these huge trains are assembled in pieces where they do what we call doubling. You couple to a track, you pull it out, you couple to another track, you pull it out, you couple to another track until the full train is complete. At that point, these trains sit on the main track. There is typically no switching lead that allows that. So main track traffic is stopped during the period of assembling or disassembling a train. We use distributed power units, called them BPU, which is radio-controlled locomotives in the middle, the back, and sometimes both places to power these trains, because they can weigh as much as 15,000 tons. That requires not only assembling the train, but getting all of the radio connections to work properly before the train can leave, and of course, testing the air brakes. So we run big trains, we run slow. The typical maximum speed for our freight trains is between 70 and 100 kilometers per hour, but that's the maximum. We're quite happy with somewhere in the neighborhood of 40. Because there's no study in railway capacity, there's no realization that train speed affects capacity. The trains are given sufficient power to maintain the slowest possible speed on the ruling grade on the line, and then maintain whatever speed they can elsewhere. So on the maximum gradient on a line, you'll see frequently our trains are running at 10 to 20 kilometers per hour. And on the rest of the line, many are lucky to make 40 or 50. The concept of timetable, since it doesn't exist, improvisation is based on the priority of trains. So the most important trains receive enough power to make the maximum speed, but they share the railway with the trains that have enough power to just barely move. Our passenger train speeds are not all that fast either. They're between 100 and 130 kilometers per hour. The average commuter train speed is less than 50. So we have a lot of single track. The majority of the railways in the U.S. are single lines. The passing sidings or loops are typically 20 to 30 minutes apart. Quite often, the trains are built so large that they don't fit in all of the loops. So it could be that although you have meeting points that are 20 to 30 minutes apart, in reality, because of the size of the trains, the loops are 40 to 60 minutes apart. On double track, there are typically no loops or sidings. The philosophy that was promoted by the signaling industry back when centralized traffic control was invented was that you can replace tracks with signaling. And there was a large promotion that if you, back in the 50s, that if you purchased a centralized traffic control system, you could tear out tracks. So when it comes to overtaking, they just use both tracks in the same direction without considering the concept that if there's always trains coming the other way, that there is no way that you can overtake without delaying trains. So we have a lot of problems with exactly that. So in addition to the slow train movement, just in general, typically yards have no long entry or departure lead to allow trains to get up to main track speed. So you'll find that the trains drag their 4-kilometer long train into and out of the yards at 15 or so kilometers per hour. Most of the places where there is a yard en route where trains must set out or pick up cars, the yard isn't long enough to accommodate the train. So you can see in this diagram, you notice that unlike European practice that we have time running horizontally, you can see the number of trains that are sitting on main tracks with the horizontal lines while they're doing station work, and the other trains that are just sitting behind them and waiting. We really need to change our system and go to open access, such as this happens in the EU, because with Wall Street and the corporations in charge, our rail transportation is minimal at best. The customers would like to have open access, so there's competition. They go to the regulators and ask for that. The railway industry fights that because their picture of open access is the customers all buy trains. And for the infrastructure, being used to a history of punitive regulation. So the fight goes on. I'm actually encouraging open access here and trying to develop a scheme that would make the industry, Wall Street, and the customers all happy and actually provide some good railway transportation in the U.S., but that's still a long way off. But functionally, we do have a degree of open access type railways, because inside of these huge railway corporations, each type of traffic is handled by an independent department. The coal trains, the grain trains, automotive, chemical, but they don't coordinate with each other. So they all schedule their traffic independently. And you have to remember that in the actually in all of North America, a schedule consists of somebody picks out a convenient time for a train to leave somewhere. They assume that it takes so many hours to get to the other end of the trip, and that becomes the schedule. Other than that, the train dispatchers have to invent the schedules on the fly and make it all work. And that even includes our passenger train scheduling. The passenger train scheduling is based on, for customer satisfaction, a train leaves a city at a certain time. And then the scheduling involves, it typically takes so many hours to reach other stations and to reach the other terminal. And so that becomes the schedule. Since the passenger trains don't have a distinct schedule and the freight trains don't have a distinct schedule, reliability is somewhere worse than terrible. So if North American railways sound like a mess, they are. One U.S. railway obtained a very lucrative contract from United Parcel Service, which of course demands precision in the handling of their merchandise. UPS will deliver your package when it's supposed to every time. And even though it was lucrative, this railway couldn't run the train on time and wound up hiring a truck company to take the shipments that they had been contracted to take by train, and then ultimately gave up the contract. These things don't make any sense to those of us who know how to run a railway, but it makes sense to the people who run Wall Street. So I've mentioned the improvised operation. The planning from the yards and the main lines is completely disconnected. So the managers of the terminals' performance is based on how quickly they get trains out of the terminal and how little time that the cars spend in the terminal, and of course how little money they spend. So there's no coordination with the main line at all. The train dispatcher will find out maybe an hour or 90 minutes in advance of when a train will run, and it's up to the train dispatcher to figure out then how to insert that train into the traffic. So our train dispatcher scheduling process is constant. Every time that a new train is introduced, it requires new planning. Every time that maintenance of way work is introduced, it requires new planning. There's no basis to work from. So our dispatchers have to be very good at improvising. This entire mess goes back to the 1980s when deregulation started. By that time, the highways had taken so much business away that capacity exceeded traffic by a lot. It's easy to run an unstructured railway when there's way more capacity than there is traffic. So management got used to that and thought that that was the way to go, but they're still trying to apply that at a point where traffic is close to being at capacity. The huge increase in the 90s came to the industry by surprise. Trade magazines were actually writing in the 80s about the end of the railway industry that they expected to come in 20 years. the traffic increase of the 90s as highways became saturated. We became concerned with global warming and pollution. It came as a complete surprise. So the industry has been unprepared for the past 30 years, and they continue to be unprepared. So here is an example of our planning process. So the top right on the slide is the plan. The planning process in this software consists of you draw a train diagram from the initial station to the terminal station of a section of line. There's no consideration for the fact that this is a single track line, as you can see from the track diagram on the left side. But regardless of that being the plan, that day, the actual traffic is shown on the top left. And to prove that it bears absolutely no resemblance to the plan for the day, they're superimposed in the bottom diagram. On a double track line, it gets worse, since of course it's assumed taking just occurs by going over onto the left-hand track, and that there's no need to consider where they overtake. You have the diagram on the top right is the plan for that day, and you'll see that if you look closely at the diagram, there's places where trains overtake and cross at the very same spot, and there's only 2 tracks. So that brings you to what actually happened on the top left and the plan superimposed over the actual operation on the bottom diagram. This happens 7 days a week. Our train dispatchers, even though they're only taught 28 weeks of fundamentals, have to be very good at making this all work. We have safety systems, technical safety systems. Our signaling systems work pretty much like they do anywhere in the world, our traffic control systems. However, our crew management system involves regulations that require a train and engine crew to be on duty only 12 hours in a period of 24. Since the trains aren't scheduled, the train crews, once they go off duty, know that it will be at least 8 hours before they go to work, but they don't know when after 8 hours they'll go to work. So an example that I regularly use was a crew who arrived at their home terminal at 10:45. They receive a copy of the plan, which shows that they will be on a train due to leave at 21:30. But at 20:30, the current plan says the train will now leave at 00:30. At 22:45, that train is now due to leave at 1:30. At 1 a.m., the train is due to leave at 3:30. At 3, the train is due to leave at 4:30. At 5, a phone call comes. It's time for you to go to work at 06:30. At 06:30, they come to work. The train is not ready to leave until 0900. This actually is a case from a colleague of mine. So the crews never know when they should sleep, how long they should sleep, when they should be awake, when they should eat. This then comes down to, we have had collisions where a crew is theoretically rested, but they haven't had any sleep, and they fall asleep on the engine. And yet the accident investigation will invariably say the crew was off duty at 10:45 and they have had sufficient rest. with no accident investigation ever going into the details that I show here of how often when they're going to work has changed. So since there is no schedule, and I've mentioned that operation is strictly according to priority, not only do the priority trains receive the best locomotives, they also arbitrarily keep the railroad clear for the priority trains. So typical instructions to the dispatchers is to keep 80 to 160 kilometers of railway clear in advance of a priority train. This means that the trains that are not priority can sit and wait sometimes for hours for their turn to use the railway, all while the crew is on duty. Since there's a 12-hour limit on how long the crews can be on duty, sometimes over a stretch of a 300-kilometer crew district, a train might need 2 or 3 crews to get across the district. Even passenger trains, theoretically, in the US, the law says have to have priority. But it is so easy to completely tie up a railway with improvised operation that it becomes virtually impossible to run passenger trains on time. Because passenger trains don't make money, the priority goes to the priority freight trains. The railway's considering that the amount of money that Amtrak pays them for track access is negligible. And there's only one word for the way we run railways, and that's chaos. The dispatchers don't know, the train crews don't know. The maintenance of way people also have no planning. They come to work at the beginning of the day. They find out what their work is supposed to be for that day. They go to the work site. The train dispatcher, who's controlling the territory, finds out at the time that the maintenance people call them for permission to use the track that there's going to be maintenance on the track. So the maintenance productivity is very low, but because of the fact that the operating budget, the maintenance budget, the terminal budget, the mainline budget, they're all separate budgets. Nobody sees in operations see the big picture. The only people who see the big picture are the analysts on Wall Street, and the only number that they worry about is the bottom line, as it were. So it would be possible to save an immense amount of money with the type of railway operation that is still taught in Germany or anywhere else in Europe or almost anywhere else in the world. But at the moment, with the Wall Street oriented railways, nobody can see that. Here is the chaos. This is actual operation for a period of 7 days. There's no pattern to it whatsoever. You can't tell on any given day what tomorrow is going to be like until tomorrow happens, and it's going to change continually as you go through tomorrow. And I mentioned already the taking 2 or 3 crews to get across the district. So to add to the chaos, the way that that's managed is that when a train crew is fresh with many hours left to work, they are of lower priority among the lower priority trains. The higher priority trains being the ones who are delayed so badly the crew doesn't have very long to work. Crews that have a long time to work are delayed for the ones that don't have a lot of time to work, whereupon they become trains that have higher priority because they don't have time to work. The relief crews, for when they run out of time, aren't planned in advance, after a train runs out of time, then they react to it. I was one time told by one of my managers I spent too much time planning and not enough time reacting. And the diagrams that you've seen are the result of spending time reacting instead of planning. Way back in the 90s, the chairman of Burlington Northern Railroad, who was an ex-airline guy, saw that the chaos in his company was costing money, and being an airline guy and being used to very disciplined operation, he set out to have that corrected. I worked on a team that he assembled trying to correct it, but we couldn't overcome the culture. However, out of that effort came another group that decided that schedule would be scheduling cars to be on trains. So the term scheduled operation in North America means that when a customer offers a car for shipment or a train load for shipment, that car is scheduled to be on certain connections on certain days. On time consists of not the clock and whether the train leaves at a specific time or even on a specific day. On time means that all the cars that were supposed to be in that train are in that train, which is why you find the example that I gave of the train departure time changing constantly. So that's an example of our control center. It looks like pretty much any modern control center. But the person actually managing the train movement is the lowest level of management, and typically decisions are made by asking higher and higher and higher level managers, or having conference calls. U.S. railway management loves to have conference calls and try to fix problems by consensus. I've been retired for a long time, but I've had many of my colleagues relate interesting stories about there's only one possible movement can be made, but his manager won't allow that movement to be made until there's a conference call and there's consensus, during which time everything else falls apart because that one possible movement to be made had to be made immediately. So when everybody is done with their conference call, the situation has deteriorated to the point where it's recovery, not operation. This is a typical train dispatcher's console. You'll notice something is completely absent. There is no diagram. They keep everything in their mind. There is no provision for a paper diagram. There's no electronic diagram. The only thing you have is to basically look at the train locations on the screen and try to project them in your mind. With 28 weeks of training, people aren't very good at that. So you'll find a lot of trains that are stopped for no reason. Trains that are crossing at places where they don't fit and such, because it's just not considered important. Once again, this detail of operation is something that Wall Street analysts don't understand, so we don't do it. Turnover is extremely high. You hire people off the street, they spend 28 weeks learning in a very elementary environment how to line signals and switches and basically make out some reports. They get into this high pressure, high stakes, three-dimensional chess game, as it were, and they don't last very long. Part of that is the having no control between the what we call Mother May I, the terminals that basically are autonomous, can hold trains on the main track without warning for as much time as they want. The maintenance of way that provides no warning, even to the point of no warning for a dangerous condition. You have to stop the trains now because we must weld up this frog or whatever the emergency is. It's a high stress job that shouldn't be so high stress or as high stress, that there's a large turnover, but once again, that isn't noticed at the top level where they keep track of how much money. We typically have most of our lines automatic block signals that are not movement authority, or centralized traffic control where the signal is movement authority. We've recently instituted positive train control. It would be ATP anywhere else, but we've called it positive train control. Being American, we had to invent our own system rather than using anybody else's. So a regulation was placed to institute positive train control that had not been invented yet. Our system depends on GPS and data radio. At the beginning of the trip, the locomotive engineer enters the train's position and what track it's on. The system then keeps track of where the train is by GPS and knows which track it's on by signal indication and switch positions. But there's no positive way of connecting train location to track location. The PTC system is typically an overlay over a standard track circuit based signal system. It's not considered a vital system. So it can actually, upon failure, be merely disconnected and the train run on the signal indications. The development is ongoing. There's still a lot of problems, but it is indeed a system that is supposed to keep trains from running into each other, overspeeding on curves, overspeeding through temporary speed restrictions and such. Our mega railways are the result of corporate mergers of many dozens of systems down into 6. Each one of those many dozens of systems had separate signal systems that were basically the same but different in details. So that now on the same railway, you can have a 2-unit signal that shows red over yellow. On one railway, that means proceed on the diverging route at the prescribed speed for the switch. On another, that means proceed at restricted speed, prepared to stop within half the range of vision. We've had collisions because a locomotive engineer has been confused over what meaning a given signal aspect had for a particular location. And you can see that example here. There are, for example, Rule 284, approach slow. There's 9 ways to show that particular signal. We have no shunting signals in North America. So when a movement receives a authority to occupy a main track, it becomes a train. It can leave the interlocking as long as it receives signals that are less restrictive than stop. It can keep on going. So there's no limit to a shunting movement coming out on the main track. There actually has to be a verbal understanding in how much authority that the signal grants if the dispatcher doesn't intend the movement to become a train. We started off in the late 1800s. The same group of people who invented time zones invented the standardized railway rule book. And that worked well up until the 1980s, again, at the point at which non-railway management came in because of deregulation. So we now have basically Canada has its own operating rule book and its own signal system. Typically, the Western U.S. is governed by one rule book. The Northeastern U.S. is governed by a second rule book. The Southeastern U.S. is governed by a third rule book. And Mexico typically uses the Western U.S. book of rules. That doesn't present a problem except in big terminals where East and West overlap, such as Chicago or St. Louis, where once again, just like the difference in flavor of signal aspect, you have the problem of interpretation of operating rules. Possessions are worked either on the authority of the train dispatcher by blocking CTC signals and giving the maintenance people specific track and time limits in which they can work, like this, or working under traffic where the track maintenance people place a stop sign at the ends of their work area and a caution sign 3 kilometers in advance. Then the trains receive written instructions that this is occurring at this location. The foreman in charge of the work, when he sees fit, will tell the train that they're allowed to pass the stop sign and enter the maintenance area. And even full day possessions can be interrupted. You can have a gang who is, let's say, replacing a turnout. And they'll be told that they can spend all day replacing the turnout, except that certain priority trains will have to be able to get through as they work. You can actually turn a 6-hour job into a 3-day job because of the way that that's done. So our passenger trains, as I've mentioned, just fall into the problem of the chaos. In fact, our operation is so chaotic that in this picture, there is a meet going on that is rare because it's occurring exactly as I timetabled it. That almost never happens. And that is the sad story of how we operate railways in North America. At some point, I expect that we're going to have to change this. I've been promoting the fact that we need real railway operation because, of course, railways are the best way to combat the transportation greenhouse gas emissions, and our railways don't do very much about that. So I've been promoting actually doing railways the way we used to, the way that you do now. And unfortunately, we don't have the expertise here to do it. So if I ever manage to convince the industry and the national government that we need railway transportation, we're going to have to import the expertise to do it. And with that, any questions you have about the sorry state of how we want to run railways, I'm definitely able to answer.
Okay, thank you, Tom. Very interesting, and I think a very interesting walkthrough about the problems you're having. It's a really completely different way of railway operation than we have here. But I would think that some problems might be the same, especially thinking about the crews and the time limit you have, about if you have train drivers on freight trains, having shift length as a hindrance is not uncommon here as well, but probably not on the same level as you have it in the US. You're perfectly on time, even with the delay. I think it was more or less exactly an hour, just as we told you before. Perfect, thank you. I think Heiko is, I assume there are some questions. We have to wait for Heiko. Heiko, do you have something for us? Or? But I already can tell you there's a new feature on this system we are using. And I think, at least for our collection, we never had so many participants than today. There are over 200, which is quite a lot. And yeah, it's nice to see that we have all these people calling in, probably from all of Germany. Okay, so here are the questions.
Okay.
We'll start with imperial and metric. That's simple. The US and Canada were, with their British heritage, imperial from the outset. And 150 years of railway has been, railway history has always been done in imperial measurements. So Canada changed over nationally to the metric system, and the two railway companies went to the government and said, who exactly is going to pay to convert all of our drawings to metric? And the government couldn't answer that question, and the railways said, okay, thank you, we're going to remain in imperial measurements, and they do. In the US, I worked with a bridge engineer from the highway department when I was, he came over to work with us as a bridge engineer for a railway project. And he told me that in my state of Washington, the managers of the Department of Transportation deemed that we were going to get into the future and become metric. And all current and future highway work would be done metrically. And they didn't worry about who was going to pay for changing the drawings because they're the government. So they set about changing the drawings and found out that a bridge that's designed entirely with imperial measurements doesn't really translate into standard size metric pieces. So they gave up the entire project and went back to doing everything in imperial measurements, and the subject of going metric just disappeared. Criticism on precision scheduled railroading. My first criticism is that it doesn't involve precision, it doesn't involve schedule, and it doesn't involve railroading. Other than that, it's perfectly fine. Some of you may have heard of him, the chief executive, Hunter Harrison. He was originally at Burlington Northern. I actually worked for him for a short time. Then he went to Canadian National, and from there to Canadian Pacific. And he was well known for cutting corners to make as much money as possible. Typically, after he left one of the railways, the condition was so bad that it cost the next management a lot of money. So precision scheduled railroading is sold to the stock market as precision is we have only exactly as much as we need. Schedule is that we operate the minimum number of trains as possible. And anybody who's a professional in the railroad industry knows that this isn't railroading. Customers are upset. They go to the regulator, the Surface Transportation Board, who basically does nothing about it. It's almost a situation like the EU. The EU is very stringent about there must be equal competition among the railway companies, but they don't consider equal competition among the modes, so that the railway enterprises are required to use their revenue to maintain their operation at the same time as trucking enterprises are heavily subsidized. And of course, we have that situation here. So the attitude of the railway industry is that if you don't like the service we give you on the railway, there's always trucks, which of course is counterproductive for any type of climate emergency. But a lot of the US government doesn't even believe that there is a climate emergency, and our industry certainly doesn't. So basically, PSR is just a code word to hide the chaos that I've shown you in the presentation. The small super elevations, they do reduce maintenance cost, especially when you consider that there's a very, very wide speed differential on most of our lines, with the least priority trains given just barely enough power to move, and the highest priority trains being given enough power to do 100. There's the possibility that the very low speed trains will produce excessive force on the low rail of the curves. I was asked by Burlington Northern Railroad many years ago to find out for them the difference in their priority trains if we reduced the super elevation even lower. And when I gave them the additional running time that it would take to reduce the priority train speeds down to the speeds of the low priority trains, that idea was also given up. Optimizing track alignment by using European rules. Well, first off, I've been informed many times that European stuff doesn't work. America is a very America-centric place, and if we didn't invent it, it doesn't happen. It doesn't work. So the idea of curved turnouts or even custom turnouts is off the table to an American civil engineer. Basically, it's almost like a model railway. You go to the store and you purchase a given a standard size turnout, and you make your track arrangement fit it. Vertical curves, spirals, the same thing. It's a matter of minimizing cost and making things as easy as possible. Always easy as possible is pretty much at the top of the list. What measures will be taken to reduce the CO2 emissions? I'm hoping that reducing the CO2 emissions is going to come down to somehow forcing our government to force the railway industry to act like a transportation company. I'm in the process of writing a book on transportation policy in which I try to point this out, hoping to get somebody's attention. I've been working with ever since 1980, when I started fighting against the new ways at the railways. I was working as a train dispatcher until 1990, trying to bring organization into the chaos fighting the system. And we're still doing that. And once the chaos goes away, the CO2 emissions go down. No, we don't use speed indicators instead of lights at all. The signal indication, the combination of colors and head locations is the only means of knowing. When it comes to route signaling, the engineer is required to know the speeds of the turnouts. And when it comes to track design, we have a big problem in speed signaling, which is most of the or route signaling, which is most of the US, in that the engineer has no way of knowing which diversing route he's going to be on. So in a given interlocking, all of the turnouts have to be of the same speed. ECP braking, I think it may be in the future. However, it requires maintenance, and in addition to air brake maintenance, and our railways don't like to maintain anything because it costs money. Right now, the ECP concept has gone away because of distributed power, so that the train handling is easier with locomotives at the front and the back, or at the front, the middle, or the front, the middle, and the back. And of course, an emergency application can be initiated from the back of the train that way. So right now, interest in ECP has gone away. I expect it to be gone for some period of time until it can be found that ECP is going to provide the same performance as distributed power for less cost. The block section length is basically, just like anywhere else, designed for the stopping distance of a typical train. When you work on a passenger project in the US, you have a big problem because of the fact that the stopping distance for freight trains can be 4 kilometers. The stopping distance for a passenger train can be 1 kilometer. So when you have an approach indication, proceed prepared to stop at the next signal, it slows down a passenger train about 3 kilometers before it would really need to slow down. This is another one of these things of cost as opposed to operation. I've had arguments with our signal engineers who maintain that 4 and 5 aspect signaling reduces capacity instead of increasing it. This comes down to our lack of advanced railway education in the universities. And somehow we have to convince people that the shorter block lengths and more complicated signal system is advantageous. But once again, because the object of railway transportation here is to make money, not provide transportation, it's going to be difficult to sell. Our high market share is based largely on monopoly. Each railway company owns the track and the service for its particular region. It is the only way to ship anything that is too big for trucks. Now, our high market share is actually not what it seems. When you compare our railway market share to our trucking market share, it's actually very poor. Our railways refuse shipments that are less than 1,000 kilometers. They prefer that be on trucks. If the shipment is going to take any substantial rail journey over that 1,000 kilometers, quite often the first 1,000 is on a truck and the last 1,000 is on a truck. So our trucks actually have a much larger market share just because of the way our railways are organized. If it were not for the size of the country, our market share wouldn't even be what it is. When you figure that railways use the obsolete measurement of ton kilometers, a nation the size of the U.S. with very high tonnage trains going over a very long distance, that ton kilometers looks like a large market share. But when you consider the lightweight shipments, the high volume, or rather high value and time-sensitive shipments that the railways won't touch, our market share becomes very bad. Maximum tonnage for freight train is basically dependent on drawbar strength and the availability of distributed power units and the minimum speed that the locomotives can maintain on the maximum grade on the line. So even our important trains now are 2 kilometers long and 10,000 tons. In order to do that, you'll see pictures of American intermodal trains, container and trailer trains that have 10 or 15 even locomotives.
Ten or 15 locomotives?
Yes. Wow. Yeah, you might have 7 on the front and 4 in the middle and 4 in the back, each one of them being 4,000 horsepower, which I can't, off the top of my mind, convert into kilowatts.
Neither.
But it's a lot.
And all are stacked with train drivers? No. Do you connect them somehow, or do all of them have to be driven by train drivers? No.
Right, they're all driven by the driver in the lead locomotive. He has a separate control stand, and he has the ability to have all of the locomotives do whatever the lead locomotive does, or the ability to control the rear units separately. If he controls them separately, the second and third set both must operate together. So he can either control 3 sets altogether or 1 set plus the lead locomotive separately.
Okay.
And of course, on a 4-kilometer train, he has to keep in mind what the back of the train is doing at all times.
And also something like is happening. We haven't talked about too much about accidents today, but I think if you have such a long train, if something happens in the middle or at the end, it's hard to keep track and to identify your problems. Probably a topic for another. Yeah, go ahead.
Just picture on a train that long with a crew of 2 people riding on the locomotive. If the train goes into emergency application, you lose all the air pressure. The conductor on the train now has to inspect the train and find out where the breakage in the train line is, or find out if his train is derailed. And on a 4-kilometer train, you can spend over an hour walking from one end to the other while the rest of the railway sits.
Yeah. I know there was an accident, I think in Germany, at least in Europe, I'm not sure about Germany, where a train derailed and it actually continued going driving for, I think, several kilometers because the train driver didn't realize what was going on. I think with these trains, this can easily happen as well. So if you have like a derailment in the middle of the train, it takes a while until you identify it. So, very interesting talk. Thank you so much. I apologize for any problems we had before, and I assume it's our DFN tool, but whatever. I think it's great that it turned out well. We had some delay in the slides, so the slides were a bit slower than you were, but I think it was completely fine. So, thank you for the presentation. Yeah?
If anybody has any further questions, just feel free to email me about U.S. railway operations. I'm always happy to answer.
Yeah, if you ever come to Europe, hopefully in the next years, we are happy to have you here in Berlin and show you around. And I think there would be lots of things to discuss. And I recognize that one question came from one of our students. Actually, I made your lecture mandatory for my bachelor students. We have one course for the bachelor students. This was actually their assignment for today, to listen to it. And of course, there will be at least one question in our exam at the end of the term. So thank you again. Thank you everyone else for attending today. I hope it was very interesting, and thank you for your questions. Nächste Woche geht es ein ganz anderes Thema. Well, maybe Tom, it's something for you as well. It's about Corona and public transportation today and in the future. Also Corona und ÖPNV heute und zukünftig. Präsentiert wird das Ganze von Dr. Jan Schilling vom VDV. Ja, ich hoffe, dass wieder viele von Ihnen nächste Woche dabei sind und wünsche Ihnen noch eine gute Woche, ein schönes Wochenende. Das kann man sich ja nicht früh genug wünschen. Ja, und dann bis nächsten Montag und schönen Abend. Auf Wiedersehen.